This chapter 2 introduces a second case study that centers around the gold mine to expand the concepts introduced in chapter 1 and to look at risk exposures more holistically. As you will very soon come to understand, the gold mine in this case study has exposure to FX, interest rate, and commodity price risks. The purpose of this second case is to show how some of the analysis we applied in the first case can be extended to this more complex scenario with as many as 3 risk exposures that can potentially be analyzed and hedged simultaneously. Our assumptions for this second case are listed next. The gold mine has minimal production risk, so we assume a 100% probability of producing 50,000 gold ounces annually. Spot prices for gold are $1,600, as are forward prices for all maturities. 3. The gold mine is for sale for a price of 450 million euros. 4. A buyer is contemplating the purchase of the mine but has only 50 million euros in available funds, so intends to borrow the remaining 400 million euros. 5. A bank is contemplating the extension of this loan for 10 years at Euribor plus 1%, but requires annual amortizations of principal of $10 million along with each interest payment. 6. To offer such thin pricing, however, the bank must be comfortable that the default risk of the loan is below 1% over its lifetime. 7. The bank accepts there is no production risk for the gold, but needs to become comfortable with the risks of adverse movements in the gold price and in the level of FX and interest rates. 8. Spot Euribor is 3%, as are all Euribor forwards. 9. The euro-dollar spot rate is 1.0, as are all forwards for all maturities. 10. The gold mine has no costs, expenses, or taxes to pay, other than the interest expense under the bank loan. 11. Annualized volatilities are 200 basis points for interest rates, 10% for FX, and 30% for commodity prices. And last, 12, the correlation in price movements between FX, interest rates, and commodity prices is 0 in all cases. Defining first the base case scenario as one in which gold prices and FX and interest rates remain unchanged until the maturity of the loan, we can quickly calculate that the mine's annual revenues from the production of gold will be $80 million, which equals 80 million euros given the parity in the spot FX rate. Of this, $40 million is required to amortize the loan's principal annually, while the payment of interest at 4% on the original principal of 400 million euros will generate an interest expense of 16 million euros for year 1. So the project would be able to service all principal and interest on its debt more than comfortably. It will also be left with as much as 24 million euros in profits. We now define the debt service coverage ratio, or DSCR, as the ratio of the gold mine's gross annual revenues to its total annual payments of interest and principal. This makes DSCR for year 1 under the base case scenario equal to 80 over 56, i.e. 1.43, beg your pardon, a healthy ratio if it were not for the volatility of interest and FX rates, and most importantly of gold prices. In fact, if we continue with our assumption of perfect stability in all 3 of these variables, the DSCR would improve every year, since the interest payments will be calculated on a declining principal balance. Indeed, for year 10, the DSCR would reach 80 over 40 plus just 1.6, i.e. 1.92, a very comfortable level indeed. The problem, of course, is that the bank cannot take for granted the continuing stability of the three variables in question. Indeed, assuming these variables move in accordance with the properties of a normal distribution, a standard assumption in finance, it is 16% probable that gold would decline by 30% or more over 1 year. It is 16% probable that the euro would strengthen by 10% or more over 1 year, and it is 16% probable that your Euribor would rise by 200 basis points or more over 1 year. If we assume for now, without considering the combined probability of these events, that all three of them were to happen over the course of year one, then at the end of that year we would see gold prices at 1120, euro-dollar spot at 110, and Euribor at 5%. For year two, therefore, and ignoring further movements in these three factors, the DSCR would stand at 50,000, the number of ounces produced and sold, times 1120, the spot price, divided by 1.1, the euro-dollar exchange rate, and divided again by the sum of 40 million, the loan's amortization for year two, plus 21.6 million, the interest on the outstanding balance of 360 million euros, applying the new interest rate of 6%, which brings the DSCR down to 0.76 and puts the gold mine well into default. Of course, the probability of all three of these adverse movements occurring at once is extremely low. Specifically, it is 16% times 16% times 16%, i.e. 0.4%, given the correlation of zero assumption, and therefore still within the lender's risk tolerance, which was defined as not exceeding a 1% default probability. But even an adverse move in the FX and gold prices alone, without assistance from rising interest rates, would still cause DSCR to reach the following: 50,000, number of ounces produced and sold, times 1120, the spot price, divided by 1.1, the euro-dollar exchange rate, divided again by the sum of 40 million loan amortization in 1 year, plus, this time only 14.4 million, the interest on the 360 million euro balance, but applying the stable interest rate of 4%, which brings this DSCR down to 0.94 and leaves the gold mine still in default. It therefore behooves us to calculate the probabilities of the various scenarios, which include adverse movements in only one, only two, or all three of the relevant variables, and in each case to all the different degrees. But this cannot be done with precision without turning this into an advanced mathematics course. For example, the scenario simulating a declining gold price and a strengthening euro would still need to contemplate the possibility of declining interest rates that could partially neutralize the pain resulting from the adverse effects in gold price movements. And the various extents of this decline would need to be contemplated individually, since they could put the gold mine on either side of a default. We therefore opt for simplicity by noting first that none of the three factors in isolation could put the gold mine in a default if the other two factors remain unchanged. In fact, you can quickly confirm by observing that even the most volatile of the three factors, gold, if even it were to decline by one standard deviation, while the other two were to remain unchanged, the DSCR would then work out to 50,000 times 1120 divided by 1.0, the unchanged euro-dollar exchange rate, and divided again by the sum of 40 million, the loan's amortization over 1 year, plus 14.4 million, the interest on the outstanding balance, applying the unchanged interest rate of 4%, which leaves this DSCR at 1.03. So just above the point of a payment default, although possibly well into a covenant default. We then assume, continuing with our simplified scenario, that if two of the risk factors move in an adverse direction, the third factor remains unchanged. This allows us to limit to 3 the number of scenarios that bear consideration. 1. Adverse movements in gold and FX, but with interest rates unchanged. 2. Adverse movements in gold and interest rates, but with FX remaining unchanged. And of course 3. Adverse movements in rates and FX, but with gold prices remaining unchanged. Each of these scenarios has a probability equal to 16% times 16%, i.e. 2.56%, and their income on the year 2 DSCR, which you can confirm in your own time if you wish, is summarized in the table appearing now. So under 2 of the 3 scenarios, each with probability of 2.56%, the gold mine would default on its loan in year 2. So the loan's default probability in that year alone is around 5.12%, or more than 5 times higher than the risk tolerance of the bank. And a hedge strategy therefore appears beyond question to be warranted. The mathematical part of our analysis stops here, since we have made the case convincingly for hedging in this instance. But in reality it would continue into years 3, 4, and so on to determine the possibility of defaults occurring in those years, even if they have not occurred earlier. In this part of the analysis, if we were to continue, the reduced debt service in each year would of course reduce the risk of default in and of itself, but would be offset by the greater magnitude in movements of risk factors that can occur over longer time periods. In reality, as you may know, a proper simulation would use Monte Carlo techniques, which generate many thousands of runs over defined time periods, based on the assumed volatilities of the risk factors and the assumed correlations between them, and subject to the assumption that the future distribution of each risk factor at any point in time centers around its forward level. But to delve into this any further would lead us far astray from the main theme of this module. Worksheet Goldmine appears now and can be used at your leisure to simulate any combination of movements you choose to derive the DSCR for the first 5 years, assuming the movements you have selected have occurred by the beginning of the year whose DSCR you are calculating, and do not change further during that year. For example, the scenario in which gold plunges by 30% in year 1 and the FX rate rises by 10% while Euribor remains unchanged is simulated by inserting minus 30% in cell D4 and plus 10% or just 10% in cell D3, while leaving the 0 in cell D5, confirming that the DSCR for year 2 under that scenario, visible in cell I4, becomes 0.94, which of course puts the project in default. If you wish to simulate the impact of larger movements over longer periods, you can do that just as easily. A scenario in which FX spot strengthens by 30% after 4 years, let us say, while gold drops by 40%, and Euribor rises by 3%, so to 6%, has just been simulated, showing the DSCR for year 5 to reach an anemic 0.65. So what is the gold mine to do if it wants the loan? The simplest answer is to hedge out enough of its risk factors to bring the default probabilities below 1%. We know this can be achieved by entering forwards on gold, Euribor, and Eurodollar spot, since this would eliminate all exposure to the 3 risk factors and bring DSCR in year 1 to 1.43 and to higher levels thereafter in subsequent years, given the declining amount of interest expense. Even hedging just the gold price and the spot FX through forwards would achieve a solid result, since, as you can quickly confirm using the worksheet, mere increases in Euribor are very unlikely to put the project in a default unless you make some very extreme assumptions. The alternatives available to the gold mine bidding group are twofolds. Either accept a substantially higher interest rate under the loan, recognizing that its default probability over its life is well in excess of 5%, or reduce the size of the loan and put more equity into the purchase. We cannot say with conviction that neither of these alternatives are worth consideration, but we can state assuredly that if they are not considered acceptable as a business matter, a need to initiate some hedging of some kind becomes a sine qua non for the success of the financing. This completes this chapter 2.